welcome back. Today we are going to be continuing on with angular kinematics, and we're going to do now a different problem, combining what we learned from the last video, with kinematics. So in the previous video, we saw that tangential velocity is equal to the radius times angular velocity, and tangential acceleration, or linear, is equal to radius times angular acceleration. And we said that we can use these equations to go back and forth between angular quantities and linear or tangential quantities. It's the same exact thing. So let's do the following problem. It says, starting from rest, the car accelerates for 20 seconds with a constant linear acceleration of 0.8 meters per second squared. The radius of the tires is 0.330 meters. What is the angle through which each wheel has rotated? Okay, so they're asking us to actually figure out what is the angle of rotation. So that is really distance. That's all it basically is. It's angular displacement, so it's measured in radians. They give us time, and they give us, of course, linear acceleration and radius. The problem is that they're asking us for the angle, which is in rads, but they're giving us linear acceleration. So based on the formula that we just saw, we can actually take linear acceleration and convert it, obviously, into angular acceleration using this simple formula right here. And that's the very first thing that we're going to do. So we go right here to our trusted sketchbook, and we open it up. And let me write over here the variables, and we can take it and analyze it. So we said that the time that they gave us is 20 seconds. And the linear acceleration, we said, is going to be 0.800 meters per second squared. These are the units that we do not like, okay? And the radius of the wheel is going to be 0.330 meters. And another very, very important thing you may have missed, it says that it starts from rest. So what does that mean? That means that the angular velocity initial, that is going to be equal to 0 rad per second. So it's going to be 0. There isn't any because it's starting from rest. And they're asking us to identify basically theta, which is the angular displacement. So we're going to start, of course, with the unit conversion, this one over here. Nobody should like this one. So we're being asked for theta. So what do we basically say? We basically said that the acceleration tangential is equal to radius times angular acceleration. So they're giving us tangential, which is meters per second squared. So that's going to be 0.800 meters per second squared equals the radius now, which is going to be 0.330 meters times angular acceleration. So we're trying to find the angular acceleration. This is a very easy to solve mathematical equation. So we divide both sides by 0.330, and we have 0.800 divided by 0.330. We clearly see that the acceleration, the angular acceleration now in the correct units, it is going to be 2.42 rad per second squared. And these are the units that we want. So we took meters per second squared and we converted it now into rads per second squared. So let's go back to our variables and let's see what they're giving us. They're giving us now time, they're giving us initial velocity, and they're giving us acceleration. So obviously it's going to be an acceleration formula, and we have two. We have timeless and displacement acceleration formula. So what do you guys think you're going to use? Because you're given time, you're going to use the displacement acceleration formula. So I'm going to first write down the linear form. Velocity initial times t plus 1/2 at squared, okay? And underneath I'm going to write the angular to show you how things change and how really they are the same things. It's just different symbols. So we said distance is angular displacement. Velocity initial is angular initial velocity times time, that never changes, plus 1/2 acceleration. Now linear becomes angular acceleration, and of course times squared again. So what do we basically say over here? Initial angular velocity is 0, so this whole thing drops out because 0 times time is going to be 0. Theta, that's what we're trying to find right here. 1/2 acceleration now, which is this one right here, times 2.42 rad per second squared times the time now. The time is 20 seconds, but don't forget, we got to square the time. So it's going to be 20 seconds, and that's going to be squared. So if we take this and we plug it in our calculator, so we first square this, multiply it by 2.42, and then divide it by 2, we clearly see that we're going to come up to 484 rad. Okay, so if you plug this in your calculator, this is what it's going to come out. And we got to go back to our presentation because we got to see which direction it's going in. And if you look at the wheel, it's going clockwise. You can see it clearly with this arrow, it's showing that it's going clockwise. So if it's going clockwise, it's going to be negative because what do we say? If it's the other way, it is going to be positive. So our answer is going to be negative 484 rad. And if we go quickly back to our presentation and we scroll down, negative 484 rad. Thank you very much, everyone. See you soon.